Okay, picking up where we left off, we're on page 135, talking about the concept of multi-part addressing. So one part of the address lets you know that you're in some geographic area, or in the network sense, you're at a network, and then the next digits in the phone number or the next digits in the postal code are subsets of that. Okay, this is not a tough concept, and I can't imagine why they devoted like 5 pages for it in the book. So let's move on. Okay. So the next thing we need to understand is how those addresses were kind of broken out. And this is a little funky. So let's just start. There's this thing called a Class A and a Class B and a Class C addresses. And so the numbering authority, when they first put this thing together, weren't thinking that this was going to be taken over by, the common man. This was designed for like military and research universities, DARPA, Defense Advanced Research Projects Agency. They weren't thinking that the IP addresses and IP address schemes were going to be used for ordinary citizens. So what they did is they broke it up into chunks. There's this figure here, and I'll go ahead and pop it up as we talk. So there's a thing called a Class A network. And so what they did, they basically broke it up into, remember the dividing line between the network and the host? And I told you that you can move that dividing line. So a Class A has the dividing line moved over, way over here. Okay. So what that basically means is there's 7 bits left over, so I can have a total of, using this scheme, I can have a total of 128 networks. That's it. That's the only number. That's the most number of Class A networks I can have. And if you're a purist, that's not mathematically correct, but I'm not going to explain that here. So let's just continue. 128 networks, wink, wink, wink. And then 24 bits left over for the network, for the host, which would be 16 million or so hosts. So that would have to be for one big ass company, right? A company that has 16,000 PCs, like maybe the Army. Okay, they could get a Class A. See how they were thinking at the time? Okay. Class B's is smack down the middle, which is identical to what we saw at the very beginning, where you have equal number. You have, 14 bits over here and 16 bits over here. I mean, you really can't count the first two for reasons that we'll describe in just a moment. So that's 14 bits, which is about 16,000, and then 16 bits, which is about 65,000. So big size companies, right? But let's say you're a mom and pop organization. So you've got 21 of these guys, which is about 2 million, and 256. So this would be a small company that you probably not going to have, more than 250 computers would get a Class C. That was their thinking. Okay. Now, the reason why the math is not perfect is Class A's have a particular bit pattern. They all start with a 0. Class B's all start with a 1 and a 0, and Class C's all start with a 1, 1, and a 0. That's why they're not exactly 8 here and 16 here and exactly 24 there. Okay. But what this really means is, if you give me the first quarter of an IP address, it's called the octet. In the dotted decimal notation, that's that first number. You give me that first number, and based upon the first number on, I don't even have to look at the third and the fourth and the fifth, the fourth. Give the first number alone, I can tell you if you have a Class A or B or C. Cool. Because of this special little coding they have in there. So let's just talk about how this works and what's good about it and what's bad about it. So good about it is, back in the day, the Army was going to get a Class A, and, the Air Force is going to get a Class A, and the Navy is going to get a Class A, and that's about all we needed for Class A's. And big companies like, Northrop Grumman and people who are defense contractors, they'd probably get Class B's. And, if you had smaller places, maybe a big university or something would get a Class B, and everybody else would get a Class C, and everybody's happy. Okay. The problem is that didn't go so well. As the internet grew, this this thing is not very flexible. Let's say, for example, you're a company, and I don't need 65, or I don't need 16,000 addresses. I need 4,000. Well, you can't give me a Class C because that's not enough. But if I have 4,000, if you give me a Class B, I'm going to waste a hell of a lot of those Class Bs. So this was not very efficient. There's this cool little graphic here. And this is the way the addresses are designed. Okay, half of all addresses, now you can tell right off the bat, half of all the addresses was designed for the military. Okay, half of all addresses are Class A's. And then 1/4 of all addresses are Class B's. And then 1/8 of all addresses are Class C's. And there's some other addresses out here. There is a Class D and an E. D is designed for doing, groups. I'm trying to broadcast to groups of machines, so I assign them a temporary address. And there's another one for other classes that was just called experimental. Okay, and even the inside here, there's some other exceptions. There's a set of addresses inside here that are not routable, and we'll get to that in just a moment. All right, the point of all this is this made sense to the people who were putting DARPA together, okay? It made plenty of sense. However, that's not exactly how it works today. So, the IP addresses were running out. So let's say, for example, let's go back to this diagram. Let's say I was a company and I had 4,000 addresses. So I was kind of like maybe one of the first ones. So I got a Class B. Okay, I got my Class B, and now we're running out of addresses. Okay, so what? Do I get a phone call from somebody saying, "Dude, I'm sorry, you're going to have to give up some of your addresses"? Well, I can't, because the way this thing works is the name of this network belongs to me, and I can't change that. Otherwise, packets will end up someplace else. So, in other words, once they started down this path, they were kind of sort of stuck. Okay, which brings us to the next topic called classless interdomain routing. So a medium-sized company who was too big for this, yet too small for that, what I needed was to move this little divider. Okay, I just need to move it over wherever the hell I wanted. Instead of having someone saying, "I'm sorry, the divider is right there and right there." Wouldn't it be cool if I could just grab that little divider and go, stretch it over? That's what this is all about. So CIDR, using my pronunciation, classless interdomain, was all about moving that little divider around wherever the heck I wanted it. Now, I could, for example, if I wanted 1,000, I would probably do what's called a /22. In other words, I arbitrarily take this thing and I stretch it over a little bit, so I have 22, meaning that's where the break is between the network address and the actual host addresses are. Okay, so there's a slash notation, and so it would make sense for a website like this, or a network rather. A network would have like I'm making these numbers up, 123.123.123.0/24. So a 20/24 is identical to a Class C. Ooh, a /16 is identical to a Class B. So, okay, there's no difference now. So CIDR really happens when there's a number between 16 and 24 or something. I mean, you could go out to 26 or something if you wanted. But anyway, the idea is you get to move that little line around. Okay, almost all routers now completely understand CIDR, and therefore we can assign addresses a heck of a lot easier now. So I'm going to show you a cool little thing. I'm going to go to the American Registry for Internet Numbers. This is the organization you go to get an IP address. And it says your IP address is, so my IP address right here, the very second, is 70.117.128.48. I'm going to click on that. And it's going to come back and tell me this is Time Warner. Okay, so this is Time Warner Internet Cable. Woohoo! And here is their Cedar address. It is 70.112.00/12. So they have a /12, which is a lot. Okay, that's a lot. Okay, well, a hell of a lot. Okay, so their range of network addresses is this. Their lowest range would be 00, and then this is the highest range they could do. So that's a lot of numbers. Cool. Anyway, the slash notation looks like that. That's what I was trying to get. Okay, so let's talk about how you and I would go about getting an IP address number. So let's say I'm sitting here at my house and I'm connected to my internet service provider, and I say, I think I want to get my own IP address and hook up a web server or something at the house. I want to do that. So how would I go about getting an IP address? So I contact these people and say, I want one IP address. And they're going to look at me and go, no. Go to your internet service provider and let them allocate a static IP to you. We've already, the iron guys have already allocated huge blocks to companies like Time Warner. Get Time Warner to give you one of theirs, okay? And they'll statically assign it. I mean, clearly it belongs to them, but they'll lend it to you, so to speak, to be a static IP address that only you can use. Okay, that kind of makes sense? All right. If I'm a big company, well, then I could go to them and say, okay, I really want an IP address. Now, the problem is all of the IP addresses are essentially exhausted. The IPv4, there aren't any more left. If you go to these guys now and say, hey, I'd like a Class C, they're going to say, we don't have any Class Cs left. I'm sorry. So there's another technique coming up it's called IPv6 on page 144. So the problem is we quite literally ran out of addresses. This addressing scheme right here that split this thing in half and then in half and then in half, so it's half, quarter, and eighth. That addressing scheme was perfect for the time, but it certainly was not efficient for allocating resources because there are huge chunks of unused in here and in here and in here that we just can't get back. So we didn't actually exceed the number of permissible addresses. That's not what we exceeded. What we exceeded is the number of addresses that we can give out, okay? Because the rest of them were taken. So it's like a reservation system. It's not like the maximum capacity of all restaurants in the world. It's how much capacity we have, how many tables we have left over at this restaurant for capacity reasons. So it's not every number everywhere. It's just that the addressing scheme was so inefficient that we ended up in a mess. Okay, so we converted to IPv6. Now, there's about 600 million addresses here, believe it or not. That's how many addresses that there really are because of some inefficiencies. And you might think, 600 million? Yeah, but there's 7 billion people on the planet, and every cell phone and every PC is going to have an IP address. And so, yeah, there were people that were hogging numbers. I deliberately showed you Time Warner on purpose, really. I mean, not just because I have Time Warner. But Time Warner actually got more than their fair share of IP addresses. There's a discussion in here that talks about how the entire country of India, which is like one of the second most populated countries on the planet, okay, Time Warner has more IP addresses than the entire country of India. Okay, is that fair? Well, probably not. Okay, this is a good place to stop for the 15-minute mark, and we'll pick this thing up again in just a minute.